These are the notes for Chapter 8, Section 6 in the 7th grade note-taking guide, Classifying Triangles. So now we're really getting into specific shapes that are going to impact us when we're finding the area of shapes and the surface area and volume of three-dimensional shapes, which is really what's key here to making sure we understand these basic two-dimensional shapes, because those are components of finding the surface area and volume of more complicated three-dimensional shapes. So let's talk about the triangle here. Lots of different types of triangles we can create by its sides and its angles, and that's where we're going here. So we'll start off with triangles by their sides. When we classify triangles by their sides, a triangle might be scalene. A scalene triangle is a triangle that has no congruent sides. Now remember, congruent is simply the geometric word for equality. So if we're saying it has no congruent sides, we're saying it has no sides that are the same. If it's an isosceles triangle, that's a triangle that has at least two congruent sides. So when we're saying the triangle is isosceles, that means two sides have the same length. You'll see the word isosceles again because we also have an isosceles trapezoid later on down the line. That's a type of quadrilateral, a trapezoid, that actually happens to have two sides the same. Most trapezoids would not have two sides the same. The only thing that classifies a trapezoid as a trapezoid, it has one set of parallel sides. But an isosceles trapezoid has two sides that actually happen to be the same. So isosceles implies that two sides are the same. And equilateral, you can see the beginning of the word there, EQUI, kind of should remind you of the word equal. That's because it's a triangle that has three congruent sides, or all the sides are the same. All the sides are equal to each other. So all those sides are going to have the same length. Now, as we shoot down into the next set of definitions there, these next three definitions classify a triangle by its angles. So we have an acute triangle. That's a triangle that has all angles measuring less than 90 degrees. That's a triangle that has all angles measuring less than 90 degrees. So when we have an acute triangle there, every single angle is going to be less than 90 degrees. If we have one angle that's 90 or more, then it's one of the other two. It might be an obtuse triangle. That's a triangle that has one obtuse angle, so one angle that's bigger than 90 degrees. Now, it can only have one. Let's think about it. If this is a triangle and it has three angles, those three angles have to add up to 180. Well, let's take even the smallest obtuse angle I could come up with, 91 degrees. If the other angle were to also be obtuse, again, let's pick the smallest one we can, 91 degrees, well, those two alone add up to 182. That's more than any one triangle could make. So you can only have one obtuse angle in order to be a triangle, and then the rest are going to have to be acute. But again, the definition here just says it has one obtuse angle. That's all it has, is one obtuse angle. Right triangle, same thing. It's a triangle that has a right angle, one right angle, singular. A right angle, one right angle. Can't have more than that because that's going to push us over the angle limits for a triangle. It can only have one right angle. Alright, so let's go ahead and scroll down here and take a look at what we've got here in example 1. In number 1, we're supposed to classify each triangle according to its sides and angles. So if we take a look at the sides here, we can see, looking at the left and the right side of the triangle there, we have one hash mark through each of those. So even though they don't give us an angle measure, we know they are the same based on the hash marks, and we've seen that since all the way back in 8.1. So if we have two sides that are the same, that means the triangle is isosceles. Taking a look at the angles, we don't see any angles in this triangle that have the right angle mark, and we don't see any that look to be bigger than that L shape. Remember, as we've talked about all the way back in 8.1, that classic L shape is a right angle. We don't see anything bigger than that, which would be an obtuse angle, so this is also an acute triangle. All the angles in this triangle happen to be acute. So we put this together, and this ends up being an isosceles acute triangle. Again, isosceles suggesting that it has two angles that are the same, acute suggesting that all the angles are acute. All right, as we go ahead and take a look at the example at the top of the next page, same directions, classifying the triangle based on its sides and angles here. So start off with the sides. We have no sides measured there. We have no hash marks there, so we have to assume that they are different. So this is a scalene triangle. Again, scalene implies that no sides are the same. And as far as angle measures here, what we do see down here in this bottom left corner that we do have a right angle mark there. That upside down backwards L means right angle, as you know. So this is a right triangle. We put this together and we end up with a scalene right triangle. All right, let's go and take a look at number 2 here. Number 2 is asking me to identify the different types of triangles in the figure and determine how many of each there are. All right, so as we go ahead and take a look at the shape here, hopefully you're seeing 4 triangles. Let's make sure you're seeing the 4 triangles before we start identifying the triangles, because if you don't see 4 triangles, you'll have bigger problems here. You've got triangles that are very clearly drawn. You've got this triangle here on the left side, triangle ABD or DAB or BDA, whichever way you want to call it. That triangle is one of our triangles. This triangle here on the right, BDC or DCB or CBD, whatever you want to call it, is my second triangle here on the right. You've got this triangle down here at the bottom, AEC or CAE or ECA. That's my third triangle. And then up here at the top, I have the big triangle when I put both of those pieces together. Big triangle ABC or BCA or ACB, that's my fourth triangle. So we have 4 different unique triangles here. And they're asking me to fit each of these triangles into categories here. Now, of course, as you can see here, as we look at the choices, right, isosceles, acute, scalene, and obtuse, you've got different things labeled here. You've got right is, of course, a triangle by its angles. But an isosceles triangle is a triangle based on its sides. An acute triangle is based on its angles. Scalene, again, would be based on its sides. And then you've got obtuse down here at the bottom, which is, again, back to being about its angles. So every triangle is going to fit into 2 categories, one about its angles and the other about its sides. And it's our responsibility to put them into the categories they belong. As you can see, the word equilateral is missing. Equilateral is the other way we talked about classifying a triangle by its sides. However, we have no triangles drawn here where all 3 sides are the same, which is obviously why it's been left off the list entirely. Okay, so let's start off at the top up there. We have right triangles. Well, we see 2 triangles with right angles here. We see the right angle marks here at this triangle up here, top left, and the triangle up here, top right. Here's my right angle mark for this one. Here's my right angle mark for this one. So those are both right triangles. So triangle ABD is a right triangle. Triangle BCD is a right triangle. So we have 2 right triangles here. All right, in the next one, we're asked to classify a triangle as being isosceles, having 2 sides the same. Well, we've got a couple of those here. If we look at this triangle on the bottom, which is probably the most obvious one, we see 1 hash mark here and 1 hash mark here. So this triangle at the bottom, triangle ACE, that is going to be an isosceles triangle because these 2 sides are the same. And then as we come up to the top, the big triangle, the whole top, triangle ABC here, as you can see, this top side on the left is the same as this top side on the right here. They both happen to have 2 hash marks through them, so that indicates those are the same. So that's going to be my other isosceles triangle. As far as being an acute triangle, as you can see, we have one of those. The big triangle at the top that we just looked at, ABC, is an acute triangle. All the angles here do look to be less than 90 degrees, less than that classic L shape. So that means that's also going to be an acute triangle.